Hello, algebra students. Mr. Lawrence here, and we're going to play some number games to start with. This is going to be a little different. We're going to try to think of numbers in different ways, okay? We're not just going to think about 10 as being 10. We're going to think about it in many different ways. Now, we're going to start this number game by using only the numbers 1, 2, and 3. Our goal is going to be how many different numbers can we make using 1, 2, and 3, and only addition and multiplication. Now, you don't have to use 1, 2, and 3 in every number, all right? So, the first thing I can do is have 1, right? Then, of course, I can have 2, then I can have 3. Now, using only one of those numbers, I can't get any more numbers, right? But now I might combine them. For example, I might say 3 plus 1 is 4, okay? But I could also think about 4, and maybe I should do it like this. Maybe I should see, hold on, let me get a line here. Okay, so I've got, how do I make 1? Well, just by 1, I make 2 just by using 2, and I make 3 by just using 3. Okay, so how can I make 4? Well, I could go 3 plus 1. Right? I won't write 1 plus 3 because that would just be the commutative property. But I could use the same number twice, couldn't I? Couldn't I go 2 plus 2? That's another way. I could go 2 times 2, right? Okay. Can I make the number 5? Well, sure I can. I can do 2 plus 3. Right? Can I make number 5 using multiplication? Well, not with just 2 numbers, but I could do it with 3. I could go 2 times 2 plus 1. Remember, I use 1, 2, and 3. Okay? And keep going. You know, can I make the number 6? Well, sure, I can go 2 times 3. Or I could do 2 plus 2 plus 2. Okay, lots of variations of it. I could go 1 plus 2 plus 3. That would make 6. I could go 1 times 2 times 3. Hey, that's kind of cool, right? Okay, so I can keep going. All right, you're going to play a number game like this in class, not for the entire period, but you're going to try to make as many different numbers as you can using a certain set of numbers and only a couple of operations. All right, so now we can think about numbers in different ways. For example, 42. I might think about 42 as 6 times 7. Or I could think about it as 2 times 21. But there are way more ways to think about it. For example, I might say it's 6 times 6 plus 6. But if you saw the example above, we know that 6 can be thought of as 1 plus 2 plus 3. So, therefore, that means 42 might be thought of like this. The quantity of 1 plus 2 plus 3 times the quantity of 1 plus 2 plus 3 plus the quantity of 1 plus 2 plus 3. Now, there's lots of different ways to think about it, but you notice this is 6 times 6 plus 6. Because of the order of operations, we'll get 36 plus 6, we'll get 42. So we're thinking about these numbers in many different ways. Okay, now the reason we do this is it's going to help us understand like terms better, and it's going to help us understand the distributive property a little bit better. Instead of just being able to do the distributive property, we might be able to explain it. Okay, let's try playing this game using 2, A, B, and C. How many different numbers can we make? Well, of course, we can make A, we can make B, we can make C, and we can also make 2. That's one set of numbers. Now, we could do A plus 2, we could do B plus 2, we could do C plus 2. We could also do A plus B. We could do B plus C. We could do A plus C. But then, who says we're limited to just using two numbers? We could do A plus B plus 2. A plus C plus 2. Let me see here. B plus C plus 2. And then we could do A plus C plus, no, I already did that one. Let me see, using three different numbers. Is there another one? I've got a feeling there's not. A plus B plus C, AC2, AB2. Yep, I got AB2. All right. BC2. Yeah, I've got all those. But I could also then go A plus 2, right? These are all different numbers. B plus B plus 2. Because we're assuming A, B, and C are different values. If they were the same value, we'd have the same number. Okay, so there's all these different numbers we could write. And then, of course, if you want to, it might be a good idea to simplify. Okay, now we can use this to help us understand the distributive property. Now, I know you're not going to be a total expert on this just by watching this video, and if your parents are watching with you, they're probably going to be very confused because they took Algebra 1 and it didn't look anything like this. Right, but that's because we're doing the Common Core, remember. Things are very different nowadays. All right, so let's see here. Let's consider the statement x plus x equals 2x. Now, some of you know this is true. Some of you think it's true, and some of you just aren't sure. Well, let's see if we can prove that it's true. Maybe even prove that it's using the distributive property. Could we think about this x as 1x plus 1x? Yeah, we sure could. And then, of course, we could think about it as, hold on, I like my calligraphic pen. We could think about it as 1 times x plus 1 times x, right? Okay, so now here I kind of see the distributive property going on. I kind of see an x that's been distributed, right? I could undistribute that x, pull it outside the quantity, then what's left here? A 1. And over here is a 1, both positive. Oops, that doesn't look like a 1. And then what's 1 plus 1? Well, 2. And 2 times x is 2x. And look at that. I demonstrated that x plus x must be 2x. And I did that using the distributive property, or the converse of it. I went backwards on it. Okay, now, does that mean that a squared plus b squared is the same as the quantity of a plus b squared? Well, let's test it. This here, a and b are just unknown lengths. Okay, and so let me draw a rectangle here. Where's my, let's see here. Let's see. We're going to need something like this. Okay, where this is A and this is B. Okay, this is A, of course. And let's see. Oops, that's a mistake. Excuse me. Get rid of him. Let me clone him and rotate him. Because I need an A plus B and an A plus B. I'm multiplying two A plus B's together. That's what this means, right? Well, what's this A plus B stuff? Well, A and B are unknown lengths. So I'm saying that the side of this square is A units long. Side of that rectangle is B units long. Therefore, the whole side of the rectangle I'm going to draw is a plus b units long. This here is also going to be a plus b units long. Now I really should finish my picture here, make it a full rectangle, something like that. Okay, and so now to find the area of this rectangle, I could take a plus b as a quantity times a plus b, right? If it was 6 on this side and 6 on that side, it would be 6 times 6 is 36. And actually, I keep calling it a rectangle. It is a rectangle, but more correctly, it's even a square because the length is 8 plus b and the width is 8 plus b. Now, what we're conjecturing, does this equal that? Okay, well, let's figure it out. Let's kind of do it the long way here. Let's find the area of this little square here. Well, its length or its base is a, its height is a, and a times a is a squared. 3 times 3 is 9, or you could think about it as 3 squared. Now, this rectangle here would be a times b. Well, a times b is ab. This rectangle here is congruent to it. A this way, b that way, it will be a times b. Now this square here is b units long and b units tall. Well, b times b is b squared. If I add up the areas, remember, only combining like terms. You know what? Let me get my highlighter out. I'm going to go and highlight like terms. Let's see, I've got an AB and an AB. Now I've got an a squared here, oh excuse me, a b squared there, and over here I have an a squared. So I'm going to combine the like terms. Now there's only one blue highlighter, that's a squared, and then there are 2 yellow, and that's going to be plus 2ab, because ab and ab is 2ab, right? Okay, and then this here is a b squared. So it would seem to suggest that if I take the length, a plus b, and I multiply it by the width, a plus b, I'm not going to get a squared plus b squared. I'm going to get a squared plus 2ab plus b squared. And that's absolutely correct. And don't worry, we're going to go over some things like this in class. I know it's new to you thinking about it this way. Just trust Mr. Lawrence. I'm going to get you through this. All right, so let me see here. I think there's, that is going to be it for the video for now. We're going to get practice with some of this stuff in class. Mr. Lawrence signing off. Have a good night, everybody.